Hello everyone, welcome back. So, we already learned the theorems based on the circles in our part 1. Part 2, we solved some problems based on those theorems. Alright. Now, today also in this session, we are going to solve some more questions based on the theorems which we have learned. Okay. Now, this is the list. Okay. Of the theorems which we have already learned. Alright. So, please go through it. If you haven't watched the part 1, I would suggest you to go back and watch that first and then come back here. Okay. Now, we'll start with our first question given here. So, two chords AB and CD of circle. This circle is given, okay? These two chords AB and CD intersect at right angle. So they make 90 degree here. Prove that arc CXA, this arc, okay? This arc plus arc BDZB, this. Okay, they make semicircle. Okay, means if you join them, it is a half circle. Alright, and similarly the remaining part. Okay, so arc AYD and arc CWB. Alright, so we have to prove that they are semicircle. Alright, now see, when I join this, okay, AC, BD, AD and BC. So the figure looks like this. Okay, now we have to prove that CXA and DJB, okay, these two arcs, they make right angle, I mean semicircle, okay. So what I'll do, the angles subtended by those arcs at the center, if they make 180 degree, then it is called the semicircle. Alright, means what? Now let's understand this. See, this arc CXA, okay, that subtend the angle AOC at the center, correct? Similarly, I am talking about arc DJB. Okay, that's obtained angle BOD at the center. Okay, now if I'll prove that the sum of these two angles, okay, is 180 degree, then I can say that these two arcs make a semicircle. I hope you get it now. What to prove? All right. So now let's do it. I'm taking angle AOC. So angle AOC equals to. Now we learned that the angle subtended by the arc at center, that is double than the angle subtended by the arc at any other segment, right? So if I'll talk about this, now same arc, okay, it will make this angle also, okay, angle, which angle? ABC. Can you see that? So this is nothing but twice angle ABC. All right. Same way for second arc, arc DZB. Okay, so what I can say, angle subtended by that arc is nothing but DOB equals twice of angle, I can say BCD, correct? Alright, now if I'll add them, okay, because I am interested in adding those two, right? As I said, we have to prove that the sum is 180 degrees. So I'll add them. Angle AOC plus angle DOB equals 2 times angle ABC plus angle BCD. Can I say that? Yes, I can. Right? Now, angle ABC. See, angle ABC is this angle, okay, and angle BCD is this angle. Now if I talk about triangle CPB, okay, so what I can say, in triangle CPB, angle CPB is 90 degree, correct, because they already told us they are mean two chords intersect at right angles. They are already given that. Okay. So I can say that angle CPB is equals to 90 degree. Therefore, the sum of other two angles are also 90 degree. Correct? Means what? Which two angles? Angle angle PCB plus angle PBC equals 90 degree. Okay. But angle PBC is same as angle ABC. Correct? See, P and A. And same way angle PCB is nothing but DCB. So this whatever we got here. So I can write that from this two. Okay, I can write that angle AOC plus angle DOB equals to 2 times 90. Correct? And hence what I can say, angle AOC plus angle DOB equals 180, means these two arcs are semicircles. So this implies that arc CXA plus arc DZB equals semicircle. Okay, so we proved this. Now similarly, what I have to do, I have to prove for the other two arcs. Alright, so let me just prove them. Now angle, see, angle subtended by this arc. Okay, now I am interested in that. So which angle is that? Angle AOD. So angle AOD equals to here DBA. Okay, this is nothing but DBA. Same way angle BOC is equals to 2 times the angle CDB. Correct, CDB. And now I can add them. So angle AOD plus angle BOC equals to 2 times angle DBA plus CDB. Okay. Now, same way, if I talk about this triangle, see the other triangle. So, angle PBD and angle this is 90 degrees. So, PBD plus CDB. Okay, they are all 90 and they make some of them 90 degrees. So, I can directly write this because the same reason. So, I can write the same reason for this in triangle BDP. Okay, angle DPB is equals to 90. Therefore, angle PDB plus angle PBD is equals to 90. The remaining two angles. So, these two angles are also 90 degree. And hence, arc AOD. Okay. So, angle AOD, first of all, let me write this. Angle AOD plus angle BOC is 180. And therefore, arc AOD. Okay, or I can say AYD, arc AYD. Let me write this. Arc AYD plus arc, which one? BWC is equals to semicircle. Hence, we prove both the results. Okay. Now, next question. It is saying that ABCD is a cyclic quadrilateral. Alright, AF is parallel to BC. See, these are parallel. Okay. And DA produced to point E. If angle ADB is 90 degree, FAE, this angle is 20 degree. Then we have to find BCD. Where is BCD? This. We have to find this. Okay. Alright. Now, first thing, ABCD is a cyclic quadrilateral. So, what can I say about this angle? See, I am trying to, I know that, okay, what I know, the exterior angle of the cyclic quadrilateral equals to the opposite interior angle, means these two angles, okay, this and this, these two are same. Now I am trying to get, this is given, 20 is given, also it is given that AF is parallel to BC. So I am trying to get this remaining part of this angle A, okay. Alright, now for that I use this fact that the opposite angle of a cyclic quadrilateral are sum up to 180 degree supplementary angles. So what I can say, angle ADC plus angle ABC equals 180 degree because opposite angles of cyclic quadrilateral. Okay. Alright. Now this is 92 and we have to find ABC. How much is that? If we solve this, I'll get angle B equals to 90 degree. 88. Okay. So angle ABC is equals to 88 degree. Alright. Now this is 88. These two are parallel. So what can I say about angle FAB? Angle FAB equals angle ABC equals 88. Why? Yes, they are alternate angles. So what can I say now? How much is angle EAB? Tell me. Angle EAB equals angle EAF plus angle FAB. So this is what? 88 plus 20 and angle EAB is equals to how much? If you add them, you will get 108. Now this whole angle is 108. So how much is this angle? Therefore, angle BCD equals angle EAB. Why? Because exterior angle of cyclic quadrilateral is equals to the opposite interior angle. You have to write this, okay? The reason for this, okay? And therefore, what I can say, angle BCD equals 108 degree. We found it, okay? Now here in this question, the angle BAE is given as 62 degree and angle AEC is given as 43 degree. We have to find the values of A, B and C which are here. Alright. Now first thing first, ABDE is a cyclic quadrilateral. So what I can say about this angle 62 and angle B? Which theorem can we apply? Yes, the last theorem. So what I can say, angle BAE equals B. Why? Because exterior angle property, angle property of cyclic quadrilateral. Alright. So B equals to 62 degree. We got B. Right. Now if I talk about triangle ACE. So what I can say for this angle, angle AEC. Angle AEC equals 180 minus 62 plus 43. Correct? So angle sum property, and I can find angle AEC equals 75. So now I have now quadrilateral ABDE. A and AED is opposite angles. So what I can say, A plus angle AEC equals 180. So A equals to how much? Yes, it is 105 degree. Now we got A also, and now to find C. So what do we have to do? C is equals to 180 minus, I'll take triangle ABF. So 180 minus 62 plus 105 degree. And on solving that, I'll get C is equals to 13 degree. Correct? So, we got all the required value. Now here in this question, ABCD is a cyclic quadrilateral. So, A, B, C and D. Now AB and CD DC produce to point where they meet point E, and here these are meeting at point F. Now we are given that the ratio of three angles. Which angles? Angle DCF. So this is 3 is 2. So I'll take this as 3x. Okay. Now angle F. Angle F is 5. So I'll take this as 5x. And E. So this is 4. So I'll take this as 4x. Alright. So now this is the exterior angle of the, see this angle, okay. Angle DCF is the exterior angle of the cyclic quadrilateral ABCD, correct. So angle DCF is the exterior angle of quadrilateral ABCD. So what I can say, angle A equals angle DCF, so which is equals to 3x. Now I got this as 3x, okay. Now if I'll apply the angle sum property for triangle ABF, so I'll get this as 180 minus 8x, correct. So angle ABC is equals to, what I can say, 180 minus 3x plus 5x, angle sum property. And I can write this angle ABC equals 180 minus 8x. Now we have this value. Now automatically this becomes 8x because supplementary angles, and now I can find the value of x, correct, using the angle sum property. So what I can say, 3x plus 8x plus 4x. So angle sum property of triangle, wait a minute, this is 180, right? So this is angle sum property triangle ADE. Now we'll get 15x equals to 180. So x I'll get as 12 degree. Okay. Now once we get x, I can say angle A is equals to 36. So I can find angle A. Now angle B equals, let me write it here, okay. 180 minus 8x. So on simplifying, what I'll get, angle B is equals to 84. Angle D equals to 8 times 12. So I'll get angle D is equals to 96. See, we got three angles. And now the fourth angle, angle C is equals to 180 minus 36. So angle C is equals to 144 degree. So we found all the angles of the cyclic quadrilateral ABCD. So students, now by the time now you understood all the theorems for this chapter, okay, based on those theorems which we have learned. Now here are some practice questions. Alright, I would like you to solve them. If you have any doubt, please write in the comment box. I'll surely reply you back. Okay. If you have done along with me throughout the session, that's amazing. If you could not do that, please, I'm requesting you to do it. Okay. If you like this video, please like it, share it and comment it. Okay. Thank you for watching.